welcome to VChem World. In this session, we will discuss on the conceptual question. So, first question is, which aqueous solution is higher concentration, 1 molar or 1 molal solution of the same solute? We know that the 1 molar means molarity and 1 molal means molality. So, first definition of the molarity, that is the M is equal to the number of moles of solute dissolved in per liter of solution. That means the volume of solution in liter. That same way definition in the molality. Molality is the number of moles of solute dissolved per kilogram of the solvent. So that is the number of moles of solute dissolved in per kilogram of solute. So mass of the solvent is 1 kilogram. So first know about the in the denominator volume of solution. That means the solute plus solvent present, and this is the only solvent, gives the 1 kilogram. How to convert volume into kilogram or volume into mass? So density rho is equal to m by v. That solvent is 1 kilogram. That means this is the 1 kilogram. So this converted into volume m by rho. We consider as the density of the water is 1. So 1 kilogram divided by 1, that is the 1000 ml. In this same way, volume of solution in liter, so this is also 1000 ml. That means molarity in the volume of solution means total volume, solute plus solvent is equal to 1000 ml. But in the molality, only solvent value is the 1000 ml. Where we know that the volume increase, concentration decrease. Volume increase, concentration decrease. In the molarity, total volume, solute plus solvent is 1000 ml. But in the molality, only solvent volume is 1000 ml. Solute volume is the different, but only solvent volume is the 1000 ml. So that way we can say that then the volume of the molality is more than the molarity. So volume of the molarity is less than the volume of the molality. That way volume is increase in the molality. So concentration decrease in the molal solution. So its answer is the higher concentration. Aqueous solution is higher concentration. So higher concentration is the 1 molar. This ethanol is an organic compound and it is freely miscible with water. We know that the mostly organic compound are non-polar, whereas the water is the polar. So like dissolve like rules. That means the polar dissolve in polar and non-polar dissolve in non-polar. But in this case, ethanol CH3CH2OH and water H2O. That gives the hydrogen bonding. When any compound gives the two molecules hydrogen bonding, so this is the soluble in this water. That way, ethanol is the freely miscible with water because of the presence of the hydrogen bonding. Next is, what is the normality of 1.5 molar H2SO4, 1.2 molar C3COOH and 1 molar NaOH? We know that the relationship between the normality and molarity. So normality is equal to N into M. This N is the factor. For the acid H plus, numbers of H plus, base number of OH minus ion, that is the factor of the N. So first is the 1.5 molar H2SO4. That means this gives the 2H plus ion. Number of H plus ion is 2. So its factor is 2. So normality is equal to 2 into molarity given is 1.5. That is 3 normal. Next is the 1.2 molar CH3COOH. This is the acid. But in this acid, this H plus, only 1. So N factor is 1. That means 1.2 multiply with 1, 1.2. Then next is the given is the base. Same rule for the base. Number of OH minus. In this number of OH minus is 1. So its n factor is 1. That way normality is equal to n factor 1 multiplied with molarity 1. So its normality is 1. Next question is, what is the sum of the mole fraction for all the components in 3-component system? We know that the mole fraction, sum of the mole fraction is always 1. In this given is the 3-component system. So we consider as the 3-component system is 3-component x1, x2 and x3 is equal to 1. So that way the sum of the mole fraction always 1. Will the molarity of solution at 50 degree be same, less or more than the molarity at 25 degree? In this question given is the temperature term. We know that the molarity is the temperature dependent. Why this is the temperature dependent? Because of the in the molarity denominator volume term present. Volume of solute per liter. That means that volume term present. It means this is the temperature dependent. So that way, first this is the 25 degree when temperature increase 25 to 50 degree. So this is the temperature dependent, that means the temperature increase. So volume increase. Where volume increase, molarity is equal to number of moles upon volume of solution. So volume and concentration is inversely proportional to. So that way volume increase, this molarity is decrease. So we can say that the molarity of solution at 50 degree is less than the molarity at 25 degree. At the same temperature, hydrogen is more soluble than helium. Which of them will have higher value of Kh and Y? We know that the Henry's law that states that the partial pressure of the gas P is directly proportional to the mole fraction of X. So P is equal to KHX. Where is the P into 1 by KH is equal to X. This X is the mole fraction. We know that where mole fraction increase, solubility increase, and mole fraction decrease, solubility decrease. So KH value is high, that means X value decrease. KH value is low, that means X value is increase. So we can say that the mole fraction increase, that means solubility increase. And in this case, solubility is decrease. So given question is the hydrogen is more soluble. So that means hydrogen solubility is more. Hydrogen, and this is the helium. So hydrogen is more soluble, that means its KH value is less and helium is the KH value is high. So we can say that the higher value of KH in helium, because of the less solubility of the helium. Where less soluble means KH value high and more soluble means KH value less.